Good evening. Welcome you all to the Tech Talk, an event hosted by the Alumni Association of the Applied Physics Department. I am Dr. Jayanta Kumar Roy, an alumnus of the year 2000. It is my privilege to introduce our esteemed speaker, Mr. Sudip Kumar Saha. Let me introduce Mr. Saha for this occasion. Mr. Sudip Kumar Saha is an alumnus of the 1968 batch from the Department of Applied Physics, Calcutta University. After obtaining his M.Tech in Power Engineering, he worked for a brief period at Eastern Transformer and Equipment Private Limited, Kolkata, as a design and testing engineer, focusing on the power and distribution transformers. Later, with the advice of the revered teacher, late Professor M.N. Roy, Mr. Saha began his career in the Signal and Telecom Department of the Southeastern Railways at Garden Ridge, Kolkata, as a graduate engineer. Here, he gained substantial expertise in communication engineering for railway operations. Throughout his career, Mr. Saha participated in various rigorous training programs and gained valuable hands-on experience in various fields, like as 6 months of training at IRR, IRIACT, Indian Railways Institute of Signal Engineering and Telecommunications, Secunderabad, covering railway communication systems such as telephone exchanges, cabling, both analog and digital microwave technologies. Completion of signal engineering classes for S&T officers, which included mechanical signaling, electromechanical color light signaling, CLS, track circuits, axle counters, panel interlocking, solid-state interlocking, and electronic interlocking. He continued technical skill development at IRACT, tailored for maintenance and project-related assignments. Exposure to information technology, microprocessors, optical fiber systems, and interdepartmental coordination courses. He served as an executive signal and telecom engineer, ESTE, during the formative years of New East Coast Railway, ECOR, zone in Bhubaneswar. He returned to Southeastern Railway by option to the Railway Board and concluded his career as Divisional Signal and Telecom Engineer, DSTE. He dedicated his professional life developing and modernizing railway telecommunication technologies. With this background, I invite Mr. Sudip Kumar Saha to begin his talk. Mr. Saha, please.
Good evening, all who have sparing their valuable time attending for this talk show. I am the very nice introduction from Mr. Jayanta Kumar Rai. I am truly honored. I am grateful to my department and RNC Da for encouraging me all along. My thanks and regards to all attendees here for sparing their valuable time. I shall now start with the evolution of telecommunication. Evolution of telecommunication in the rail industries in general and Indian railways in particular need communication for their number one, train operation, number two, administrative function, number three, data transmission. In the subsequent slides that we navigate, we shall come to know about this aspect. Next. Dedication, yes. This presentation is dedicated to my esteemed teacher, late Monindranath Rai, an alumnus 1928 and ex-faculty, Department of Applied Physics, Calcutta University. I am deeply grateful for his guidance in encouraging me to switch from electrical engineering, power special in MTech, to electronics and communication engineering, my job under Signal and Telecommunication Department of Indian Railways. I was then a design and testing engineer in a local factory, manufacturing power and distribution transformers. I shall always remain indebted to him for showing me the right path at the right time. Next. Telecommunication in railways did not grow in isolation, rather as an essential tool for and in conjunction with railway signals. Hence, to appreciate fully the functionalities of this department, a separate presentation on signaling is required, which is not in the today's scope, which is only in communication. The undermentioned institute, this is the main training center for this department. Next. About my presentation, I will say that the timeline cited are approximate. My experience, as also the latest practices, will be mentioned here. Sketches from online sources are indicative and subject to fair use policy for all such, that is, education and learning purposes only. And disclaimer, system discussed conform to the global standard like ITU, International Telecommunication Unit, International Union of Railways, European Telecom Standard Institute, etc., as also railway manuals RDSO specification. In case of contradiction and discrepancies, if any, railway board's guidelines and RDSO specification should govern. Next. In the beginning, railway had to depend on telegraphy and transmission of Morse codes for exchange of dispatch and reception information of train in the section. Now, railway at his disposal had only one GI wire rented overhead iron wire rented from PNT department, who is used to work by earth return circuits. That is the beginning of railway communication. Next. Meanwhile, telephone came in the scene, and for direct contact between railway officials. Telephone network for the traffic controllers are omnibus circuits connecting them to station masters, one to many, and individual, that is one to one. Meanwhile, railway had started erection of their own overhead alignment, surrendering the PNT and saving on huge rental. Now, here I shall just share one of my experience, that in this telephone will be working, it will not work on metallic return. It will not work on earth return. It will work on metallic return. So 2 words. So, and the control telephone, the traffic controller is a centralized person overseeing the movement of the train in the section. So he has his control telephone will not have any dialing system. How he will call? So that STC, Standard Telephone and Cable Company, England, they came up with a solution. In those days, what they did, they provided the traffic controller with a rotary key mechanism to transmit 17 pulses. And the station master selector, that receiver, is to receive that code, and with some ratchet and pawl arrangement, it is a disc, rotating disc, that will connect the circuit for polarized relay, and the bell circuit will ring. So now with the transmission of 17 pulses, all the station master will come online. Now that is omnibus circuit. But one-to-one, how he will call particular shape from he is sitting at Sialda, he has to call Birati, he has to call Ranaghat. Then how he will do? Then they cleverly, the same rotating disc in the station master's equipment room, they are cut and designed in such a way that the disc will move with the in steps of say 10 pulses, then 5 pulses, then 2 pulses. That makes 17. Another next station, he may be given 8 pulses, 5 pulses, and then 4 pulses, like that. And nobody's selector will be duplicated. So his selector only will move. That is how this electric ringing was achieved with overhead control. I am not there. The main control is the controller sectioning the running of the train. We call it section control. But besides that, we have deputy control and a block control. Block control is that by that time block instruments have come. All of us must have seen a token will come out, but it also has a telephone. The token is the authority for station master to enter into section and hand over it to the next station, otherwise another train go. That is not the part of today's signaling part, but they have got a block telephone also, but in that self-ringing arrangement is there. Because it is an instrument, so some ringing arrangement was made, so there was no problem. Next. Then radio, meanwhile, no, it is okay. It is okay. Next, this is 5 watt and 25 watt analog VH what is it? We know it is in frequency band of so and so for communication between all driver, guard, field officials with station masters adjacent. And these were very useful for coordination during accident and restoration of abnormal. So when abnormal situation happen and where telephone facilities are yet to be provided. Next. Now this heading is underground quad cable, traffic control and emergency sockets. Now what happened with the introduction of 25 kV AC, these overhead telephone lines were prone to induced voltage and it became very noisy and the controllers was unable to work. Listen to the SM. Then railway decided what to do. We have to transfer them to underground cable. So it was quad cable. Quad means there will be 4 wires, and 4 wires, the 2 wires for transmission and 2 wires for reception. And that 2 wires will be twisted. Why twisted? Because it is not only one quad. It will have some 16 quad it may have. So other circuits also will work. Traction control, section control, remote control, emergency control, like that will work. So this may have some crosstalks between them. So these wires will be twisted. So by this twisting, that cancel out any induction residual, it cancel out. And this emergency socket, I am telling, every that remote locations, every 1 kilometer, there will be socket, and there will be tapping will be taken from that quad cable, and in that, when some emergency happen, the train driver, guard, they can come down, and every 1 kilometer they can directly give exigency message to controller. Next. This analog microwave system. I have told in the beginning that railway require for administrative function, say between say zonal headquarter, divisional headquarter, zonal headquarters say Fairly Place, and divisional headquarters Sialda, Asansol, Dhanbad, like that. So for that we require long distance communication, and that is analog microwave communication system. So this microwave communication system, they will have, it is initially it was cluster type, subsequently it was solid state, that we will see very soon. But meanwhile I will share my experience that for microwave signal we have to mount parabolic antenna in the tower. The direction of tower is a very challenging task. We have to give all data to the civil engineers. They will erect the tower. But how we will give them data where the tower is to be erected? Then that Survey of India published topographical sheet. In that sheet we have to plot that microwave hop at an interval of 30 to 40 kilometers, and there we will note latitude, longitude, altitude, everything. And after that it will be plotted. We have to make a field survey whether those location according to the topographical sheet it is suitable, it is tallying or not, like that. And civil engineering will have another, they have to create a microwave room wherever the tower and antenna will be there, a microwave room with some quarters, railway quarters also. Those things will be ancillaries of secondary important. Then comes next. Then come digital microwave system. It is only a great improvement, because that mechanical system or electromagnetic system, whatever you call clustron type, but this is solid state, gun diode, some trapper diode, like that is the source of microwave, and that analog instrument work on frequency division multiplexing. Here it is time division multiplexing. Time division multiplexing means within a very microsecond slot, everybody can use the channel. Lot of channels will be there. So I have written 2 megabit to 30 megabit. There may be, so they will carry by pulse code modulation and time division multiplexing. It will go signal strength, which is the very vital for parameter for successful, for a good transmission. So here it is much improved as compared to, so analog has been phased out. It is totally digital now. Next. Fiber optic, as you know, then the telephone exchange come, and fiber all communication, whatever I have said. OFC is a very important backbone for the Department of Signal and Telecommunication. Next. Now global GSM-R, Global Standard Mobile Communication for Railway. Now this is what happened. This mobile train radio communication, this is the latest technology. We have come out that time. It has been introduced recently, and it follows the global standard. Global standard, as I have told in the very beginning. Now, railway has to, some features of the special features of the railway has to be incorporated in this. Simply we cannot use it. We shall see the architecture in the next slide. Then we shall be able to understand how cellular technology is being made use of in for railway operation and communication purpose. Next. Yes, this is the normal tower geographically, that these are the mobile phone. We are moving these at cell. One cell is say at Shambhajar, another at Shialda, another at Moulali, all cell to cell. They are now connected by a base station controller. Then in the center there is master switching controller, some switching mechanism. There the database, all those modules are nothing. That AHL or home location register means all the subscriber data. Say it is Airtel or Vodafone or Jio. So all the subscriber, all database will be controlled here, switching there, and some controlling equipment and modules are there. They will be modules are there. They will be handing over. They will decide. They will verify the authenticity of the subscriber, and they will make handover. And we will see now next slide how railway is making use of that. Next. Yes. Here we can see that the train on the left hand side, that is actually now mobile. As if the train is the mobile equipment, and the track side antenna, those cells, just a symbol is given for antenna. We have to erect antenna also suitably. And in the center we are going, the switching centers, what we have seen earlier slide, everything is there. That's controlling. Now, the railway special feature is one important feature is location addressing and functional addressing. It means, suppose I wish to contact Rajdhani Express at Mughal Sarai. So I need not go here and there. I will simply connect him. So by virtue of this circuitry and this network and functional addressing, I used to call all the station master, I used to call all the yard master, I used to call others. So this functional and locational addressing for railway, it is very important. And those switching center is just like the earlier slide. This is the switching center the railway has. The special feature railway has to incorporate. And next. Then communication for Kolkata Metro. So Kolkata Metro once comes, it is there is a difference in metro that we are commissioning now, and previously when Dum Taliganj in India, this was the first time. So that time the track also was little bit more than 1.5 meter, but now the whatever track is being, the track width is little more than little less than 1.5 meter. So present metro railway track is less than 1.5 meter. That is a civil engineering interest. And previously, that Dum Taliganj, it was just for information I am sharing, it is little more than 1.5 meter. And now it is 1. Now in metro, what happens? This VHF walkie-talkie set, those are very popular set for driver, guards, field staff. They can communicate between them. But inside the tunnel, the normal propagation of electromagnetic wave is ruled out. So what to do? Then the designer, the scientist, engineer, whatever I say, they have cleverly, that we will see with the following slide. So, and in this slide, there is another idea that tetra trunk radio, terrestrial trunk radio communication. This is also just like telephone exchange. We know that we dial and via the telephone operator or automatic switching, electronic exchange, automatic switching we connect. But this is a radio communication that trunking function will be done centralized. And as a result, what happens with minimum number of channels, we can communicate, and some mission control, the emergency communication, we can avail from this thing. I am having little bit trouble because of the small slide is very small. I am not able to read properly. So whatever I am describing is from my memory only. So now this tetra communication. Now there is CBTC communication. Now it is, even though it is not a signaling presentation, but CBTC, that metro rail, it is not there in Dum Taliganj. But the new metro, that east to west metro, Salt Lake to Howrah Maidan, these are all airport, New Goria airport. These are all the latest communication device, communication based train control. Next. Then this is the tetra, what I have actually described. We can go to the next for illustrative sketches. Next. Left side we are seeing tetra with similar cellular type of thing, having radio switching center and very much economy and functionally also much better. And this is preferred by all police department, hospital and rail transport, of course. And in a tunnel communication, it is very useful. Now, here I have shown how communicate when electromagnetic propagation not ruled out inside the tunnel, how to do it. So engineers decided that coaxial cable, it carries radio frequency signal. So they devised it, they call it leaky coaxial cable. The coaxial cable inside which the radio signal will flow will be exposed, that coaxial cable will have a copper sheath for protection purposes. So every, say, 100 meter or 200 meter, 500 meter, that cable sheath will be cut. So once that cable sheath will be cut and the radio frequency signal will leak, there will be leakage. And that radio signal that the driver is having his antenna on the train, that he will catch that one. Now there is a procedure how it is functioning. Functioning is also that suppose station master want to talk to the train driver inside the tunnel. He will speak his antenna at his place. There will be converter radio signal to electrical signal to optical signal. There is optical fiber is also being laid. Optical fiber it is laid. So by optical fiber it will come toward that base stations. There will be base stations in road, and there it will couple to the coaxial cable. That also will be there, and couple, and that will leak, and from that this station driver will get the wireless signal. So that is there. Next, and here see, I have given a brief description of CBTC signaling, although it is because it is communication based train control, and it is the latest worldwide. So it has got 3 building blocks: automatic train protection, automatic ATP, automatic train supervision, automatic train operation. So in a simple way, I will just describe that automatic train supervision, that there is OCC, Operation Control Center. They will give some command, run your train between say Fulbagan to Shialda. So this ATS, automatic train supervision, he will check up the track condition with some track condition. There are some devices connected to the track. There is signal interlocking, some data, everything it will check, and then it will give the order to the automatic train operation, that is driver. Meanwhile, there is a control in CBTC signaling. In normal signaling, it is station master used to control the reception and dispatch of the train. But here, there is a zone controller in the station. That zone controller will study electronautically with all those programming is there. They will sense the track, they will sense the point, and whether overall there is integrity, is it safe for running. Then they will issue an movement authority to the ATP, automatic train protection. Now this ATO, when he will run the train, if he makes any error, if there is a pilot error, then ATP will apply emergency brake. Emergency brake, even if he speed profile, everything are violated, it will apply emergency brake, and that will protect. So that is the system CBTC, because there is no signal at site. Conventional signal, no signal post is erected, no color light signal or whatever it is. Next. And this is the same metro, only underground Hooghly river well, this optical fiber and leaky cable, coaxial cable, whatever I see, these are to be protected by waterproofing, foam dielectric, so that ingress of water, moisture are laid in sealed, pressure tested ducts. That is the protection they are taking below the Hooghly river. That is it. Next. Now, long-term evolution in railway. So, this GMR, what we have said, that was a 3G technology. Now, this LTER, it is 4G LTE. It is 4G technology. So, it is more advanced in all respects. And there are multiplexing I have mentioned, because those cleverly multiplex so that channel utilization is more, speed is more, and this it works in low frequency and high frequency also. 1 gigahertz, because its purpose is for high speed transmission of data. It will high speed transmission of data, but coverage become less. But for greater coverage, we have to use 470 megahertz. Then architecture and railway specific features are elaborated next. This is now, that is the LT. This is for. This is the LT architecture. You see this those towers like of thing, they are now given a new name. Evolved Universal Train Radio Access Network, like that. We should not be threatened by this acronym. I also get this terrification. This user equipment, that is the mobile, they are the interface equipment. But this, as it has evolved over GSM-R, what we have described, this is having more functionality, more supervisory protection and emergency communication required for railway, and the central switching system, that function is more or less same, more or less similar. It is, but that GSM-R, that was circuit switching network, but here it is packet switching network. It is very fast on the same medium. So these are the packet MME mobility management entity. They will check up authenticity of the person want to communicate with railway. All these things will be checked here. One register database also is there. Then server gateway, SDN server gateway near packet data PDN, packet data network, and they are connected to external interface with external physical world also. It is there. Next. Now, railway specific festival. It is better. I am not able to read properly. Automatic train protection through train collision avoidance system mission. These are the specific railway feature, because automatic train protection is very much required. It is the train collision avoidance system. So these are being achieved by this infrastructure. But it is not there in the normal LTE or 4G LTE that we use our mobile. But these are the specific features for the railway and very, very important. So then here we will see let us go to the next infrastructure. Next. This is that structure 4G LTE that we have seen earlier, one slide, two slide before. Here we can see the functionalities. That is the application servers, then section initiation, SIP section initiation protocol, then TCAS, then level crossing gate, then IoT. The same thing railway, those nodes they have incorporated, and very critical function they can execute. There is MCPTT, mission critical push button telephone, then mission critical data communication, mission critical video communication, that is onboard loco camera will detect the tunnel, bridges, and the condition of the track, obstruction. All this will be related to the central control on real-time basis. It will go. That is the idea of this. Railway has incorporated 2 locos are seen. So the train collision avoidance system, these are also incorporated here, and this switching system, all are there. Next. This is IoT and smart railways. Now, like Industry 4.0, which employ IoT, then artificial intelligence, then edge computing, cloud computing, just like Industry 4.0, the railway, all the strategic point, engine, coaches, wagon, track, tunnel, bridges, they will be connecting smart sensors with intelligent software. They will communicate the position on real-time basis so that predictive maintenance can be done, preventive maintenance can be done. So before the system fails, the components fails, the necessary protective arrangements can be taken. So with that, we shall economize our maintenance cost also, and reliability and functionality, everything will improve. These are the latest development in railway. Next, this Kavach communication. I am not able to read. Anyway, I will just. Can it be enlarged?
Yes, yes. Is it
Okay, okay. Doesn't matter. I will manage. This see, this is main idea is it is the government of India, Atmanirbhar Bharat, with that concept, because it was conceptualized in 2012 and standardized this TCAS train collision avoidance system. It was renamed as Kavach. Kavach means armor, which protect. And our local vendor, RDSO, with them some 3 vendors like HBL Power System, then Medha Project, then some Carnex Microsystem, these 3. And other vendors also nowadays are flocking. This is very, very successful, but not yet implemented. They can, to begin with, they will implement it only at some strategic place where it is required. So progress may be 5%, 10%. And that below I have given Press Information Bureau report. For that we require optical fiber, microwave, UHF communication, ultra, all those things, whatever tower is required, those are the progress so far. This is 6 months back. This that I have just kept it here for reference purpose. Next. This is the Kavach communication. Here we are connecting some this RFID, radio frequency, that is the radio frequency identification device, that is connected on the track. Say for an open track for a 10 kilometer, say every 500-meter interval, if we connect the radio frequency tag, then we can connect some 20 tags in between in the open section. But as we come to the station area, yard area, there I have to fix that radio frequency tag below the every signal, every point where they are joined, every joining of the track. So strategic points, that those things are to be. Now in the loco, they have loco board equipment, loco operating indication panels. They will communicate via UHF to the station master. Will also have this system of Kavach. Station master also will have. So they will supervise all the signaling, otherwise safety features. We call it interlocking, but not. It is electronically by software. It is achieved. So they will communicate, and they will take the help of global navigational satellite system. That also, and the global positioning system. These they will monitor the train position of the actual position of the train, and combined with the RFID tag which are connected on the track. So the stakeholders will know the correct position. And it is only, of course, we have got to do nothing when they will be violated, because this we are seeing that communication left side, and then one below, those are connected with loco. They are having this satellite transmitter, receiver, all those things. They are connected with that. With that system, it is all automatic. No manual intervention is there for implementation of the Kavach system. So that is just I have given an idea because it is all on communication. It has advanced so much. In our time it was not there. Next. This voice over internet protocol. This is a train control system, then telephone exchanges, then railway has own subsidiary Railtel Corporation. They have done massive installation of optical fiber. On that, they are connecting to all telephone exchanges. They are interconnecting by internet. And the station master, the plan is to provide the station masters with IP telephone, internet protocol telephones, and these are all in IP network. In this connection, I may request those who are associated with networking that one important thing, because it is very much being employed now. The IP network, internet network, or the Ethernet bone, or router, hub, switch, whatever we connect, these are almost known to all of us. But what happens when the hops are more, when the distance are more, that this router, hub, switch, router, they have to look up the routing table. When some packet comes, these are all in packet transmission. Some packet come where it will route. He have to check the entire routing table. It will take lot of time. So to economize that, multi-protocol level switch, MPLS, I have not mentioned here, MPLS, multi-protocol level switch. It is very, very important and very, very useful. Suppose from Howrah, some packets are going to Kharagpur. It is not train, but it is actually in connection with the communication. Now, after going to Howrah, they will, instead of looking on the routing table, after reaching Kharagpur, they will, suppose one train will go to Purulia, another will go to Bhubaneswar, another will go to Tatanagar. So they will label it. Instead of giving which is IP addressing, dotted decimal convention is very confusing. So to follow all these things, it is difficult. So what? They will attach a level. In such a way that once they go, they will Purulia, they will send Purulia, then Bhubaneswar, they will send Bhubaneswar, Tatanagar, they will send Tatanagar. So this MPLS in this connection and voice over internet protocol in the WhatsApp, we are talking from WhatsApp, that is also voice over internet. So this MPLS is a very important concept. So networking, those who are associated with networking, they should concentrate upon that, how this IP Ethernet and this MPLS can be integrated. Multi-protocol level switch. Next. Real-time train information system. So this is our Center for Railway Information System that is there in Delhi. So they are giving some facilities with this system so that they can collect the traffic data, how many trains are running correct time, how many is late. So for public amenity to address the public about the train position. In case of any emergency, they can do. They have got the real-time train information system. They have got no role in the operation of the train. So far, whatever we have seen, they are all connected with operation of train. But here, this real-time train information system, it is for the convenience and amenity. It is a public amenity. At the same time, the traffic department can plan which train should go, which train should be given precedence, which train should be delayed, like that. Those decisions can be taken. Next. Future development, that emerging technology like 5G. Now, so far we have talked about 5G, that in 4G we have seen E node B, evolved node B. But here for 5G, it is G node B, G for Ganges. It is G node B. So, and this is the future railway mobile communication system. And 5G is not a mobile. I also have a 5G mobile. But it is not only 5G mobile. It is used as 5G technology is used in for automation, industry, everywhere, vehicles, so many industries. The 5G has connected because it is very high frequency communication. And here we have mission artificial intelligence also, edge computing, money that our track, wagon, coaches, tunnel, bridges, everything, whatever data is being generated will be sent, and by artificial intelligence analytics will be done, and we can decide how, if the conditions are safe for running the train, and what executive decision is to be taken, supervisory decision that can be taken. So these are the 5G, AI, edge computing are expected to further transform railway operations and enable even more advanced application. Next. Thank you all. It's my compliment. I am honored to have this, be able to give this presentation with parts, with advice and persuasion of Mr. Ravin Chakravarti Da. So thank you all. Any question? If any question, I will be able to, I know I will share with you. If I do not know, then I can afterwards give in our group also. There is no problem, no hesitation in asking. I will be rather happy. I may also learn out of the question.
Thank you, Mr. Shah, for delivering insightful talk on the evolution of telecommunication in the Indian Railways. The session is now open for questions and discussions. Attendees are encouraged to present their queries, which Mr. Shah will address. Please.
Yes.
I think no questions from attendees. So can I make some questions? One or two? Mr. Shah?
Yes, most welcome.
What are the type of sensors used in automatic train protection system or train collision avoidance systems and mission critical services? If you name some few sensors which are
these are hardware and programmed sensor, depending on, suppose we have said that RFID, radio frequency identification tag, this is also a sensor. This is also a sensor. So there is no speciality, because we can, any hardware, electronic component programmed according to the requirement of the field. One example only I am able to give you now, that is a RFID. That is also a sensor. And that will communicate. There will be some embedded program, I think embedded software, these things are there. So the sensors are just like that. They are connected with some intelligent software added. So exactly that RFID, but these are coming now for the tunnel, bridges, for obstruction, track obstruction, all need not be similar. So now this is a camera, video surveillance is there. I have shown in LTR architecture, video surveillance, that is by camera. So that is also relate to the, immediately that position is related to the control center. It goes to the control center. Here it is performing in a different way, but directly connected to the track. There will be, depending on the necessity, that is to be explored. It cannot be rightly said the what type of being used everywhere.
Okay.
So
thank you. One more question. In railway, what is meant by asset reliability? What is meant by asset reliability, and how it is measured or monitored through IoT? Can it be?
Yes. That asset monitoring, nice thing you have said, very important. That industrial Internet of Things in Industry 4.0, that IoT devices are meant for asset monitoring only. Now you say in that IoT device, what are the components, what are the hardware, what are the programming has been done. That cannot be immediately shared information. It is as a IoT Internet of Things, that is only asset monitoring. Because our machines, our infrastructure, they are not, they by with the use of this sensor, this IoT device, they become live. They become part of the network. So far we know track is only track, stone is only a stone. Now the stone also can be a part of our network. So that is the technology they are aiming.
Okay.
That is asset monitoring.
Thank you, Mr. Shah.
Welcome.
I am RP Hajra, Ramprasad Hajra in 74 batch. I have two questions.
Yes.
One is actually in 25 kilovolt high tension line, overhead line. Is there any sensor being used? How much induced voltage is being induced in a particular distance? Say within a 1 meter distance from the overhead line, is there any sensor which can say me that this is the induced voltage? Or if I put some protection, it can say me this is the induced voltage available. Still, the amount of voltage being induced.
However, your question is very much relevant, but it pertains to traction department, because with traction department 25,000 kV, that is previously it was steam loco, then diesel, then replaced by electric loco. Now we don't coordinate for these telephone lines. When we are taking underground, we have decided we do not, there is no coordination with them for that. Because this underground telephone line are working independently. Once we have taken that, taken care of, that induced voltage problem is taken care of. Now, how much induced voltage is a valid question. If it is 20, suppose it becomes 11 kV, it may be less. If it becomes 440 volt, then maybe still less. So that how much instrument or how much measure, one is by practically we can measure practically with instrumentation and telemetry. That because that is a traction department, I cannot go deep into it now, right now. If at all is there, I shall look for some literature.
And another thing, actually, I was also wondering if there is any sensor available. Yes, if somebody is working, say, near the high tension line of, say, 25 kilovolt overhead line, say, if there is any sensor which can induce, there is a light or illumination is there. I am seeing some sensor is there. If you use it on the top of a helmet of the say, operator or say, worker, so that it can be visible that, yes, the overhead line is now charged. So is it there?
Yes. It is. I have told so many things about our communication. Our communication is not the end of the story, because this electrical department, traction department, they have got their own circuitry infrastructure taking care of all these things. We have taken in a telephone line. We take care. There should not be loss transmission. There should not be induction. There should not be noise. But here we deal with millivolt, microvolt, but they are dealing with 1,000 kilovolts. They will have their own safety circuitry, very much relevant. All protection circuits will be there, whatever be circuit breaker, sensors, everything is required there. They have got their remote controlling. That remote control we maintain. We extend the remote control, and their remote control apparatus that operate in our system. By that, but we are not. We are only giving them communication. Now they will, from remote, sitting at Howrah or sitting at Shialda, they will do the changes of the whenever required power line change, three-phase lines. They will be changing. There is a method for them. So when the train moves with the traction, that pantograph is there so that it doesn't become heated. So one alternatively, these are taught Our professor, late Professor M.N. Rai, he also used to give in our classes this example of this traction, as you have asked this thing. He used to ask a lot of questions and share
A few days back,
knowledge.
I went to his factory,
Huh.
and his younger son is running the SO now. I have some discussion with him. Sudip, I will talk to you one-to-one. I have some understanding, clarity of understanding I require, and I want to know some connected, concerned persons who can advise us, because we are working in such field where the high tension line is live. So we
Acha.
want to understand how to go forward.
Acha. I can try. Let me say, it is not in my department. This will be the traction electrical engineering department. They will be. But anyway, we have coordination with them. There is no, always coordination is always there. Because when we go for signal, it is not a presentation on signal. With traction, because of that mast, our signal staff, erection of the signal, fitting of the signal, working of the signal, those lights, those will be also affected by the overhead traction line. So definitely we have to take protection for that, and there will be joint report that distance, that the separative distance, if it is whether it satisfies the condition. There is a traction is there, Indian Railway traction manual, where whatever questions you have asked, you will get the answer for all this. If you, I can, that much I can tell you. If you can collect the Indian Railway traction manual, whatever your questions will be satisfied.
Okay, I will contact you to get the other information.
Okay, welcome.
Any more questions? Any more questions?
Actually, I want to say something. Thank you, Mr. Sudip Kumar Saha, our senior alumni, for enlightening us with the latest telecommunication used in the railway. My one question is, you have mentioned that your railway telecommunication uses some exchanges, switching.
Yeah.
I want to know what type of switching technology is used by your rail corporation.
See, if let me start from the beginning. That in the beginning it was Stroger type of telephone exchange. This is electromechanical. Electromechanical switching technology was electromechanical selectors. They will connect, all subscriber line will be connected separately, and this will again rotate. There will be vertical movement, horizontal movement, and they will connect. Then same thing was converted by the crossbar exchange. It came. Subsequently, it became fully electronic, like Japan, Okai one company was there, this. And even our indigenous, the Center for Development of Telecom, CDOT telephone exchange was there. Mr. Sham Pitroda was the founding, he was the brain behind that. Center for Development of Telecommunication. So we had our own telephone exchange also. So now which one they are using actually, that switching electric, mechanical to electric to electronics to solid state. That is the basic. Now which one is being used, that to find out. These are changes, sometimes new exchanges comes, developed. And we have to go by cost-benefit analysis also, so that simply some development has come, we can. Railway is very particular about that. They will not spend unjudiciously. They will spend judiciously. So that is the idea.
Actually, thank you for enlightening us. Actually, in the real telecommunication scenario, you have correctly said that is from Stroger, then crossbar, then electronic. Usually, actually, in the 1985 to 90, Indian telecommunication system used in the E10V system all over the world, all over the India. Then after E10V, then your EWSD system, that is based on the Siemens, actually, based on the German, actually. Now it has converted to next generation network, what is used in the telecommunication in India. That's why I am asking you.
Yes, yes.
Thank you.
Now that I have given, I do not know. I have to find out how far is the progress. Benares, some 15-20 station masters has been provided with internet telephone, IP telephone. Now it's a mixed reaction. Whether it is, we have to get accustomed to that. There's some is telling, no, it is not convenient selling. When it is internet telephone, those telephony also telephone exchange, that also internet for IP based. From that I have seen, I have, voice over IP, I have told, that time I have just referred to telephone exchange. So now this also we are seeing. And there this MPLS I have seen, that Ethernet backbone I have seen. So the telephone exchange, whatever is designed now, it has to come there so that the entire railway, all the telephone exchanges, anywhere to anywhere, all will be covered up in the same network. So, railway has having their, just like that, where railway have got their Ethernet railway network, that is, they have got email. We give them email also. We do it. Our staff, or we do it. railtel.gov.in. That is they have got our URL website. On that, just like a gmail.com, in railway we have railtel.co.in. And it is given everywhere in a priority, because that is the inner communication. And some connectivity to the outside world is also there in a limited way, because general public do not enter into this thing. Then there is common user group like that. So railway is using whatever technology is available, same thing, but they have to modify to suit and tailor according to the railway's own requirement, safety requirement, reliability requirement. There is no dearth of efforts from the railway side. That much I can tell.
Thank you, Sudip. Thank you.
Thank you. Welcome.
So no more questions, I think.
Can I ask a question? My name is Dibendu Datta.
Yes.
So thank you, Mr. Sudip Kumar. That presentation was very nice. Although I did not join from the beginning, I joined slightly later, but still I saw you presenting about 5G. 5G and its usefulness and the utilization within the railway network system. What exactly are basically the 5G part? How does it, because 5G nowadays is very, very prominent and it is used everywhere. Automotive to whatever you can think of, to factory, inside the factory also.
Yes. We have to explore. That is the very fantastically. We thought when I purchased a mobile phone, 5G, it is just a mobile phone. Subsequently, I come to learn that 5G is not for that. Their infrastructure is different. But I have not shared that. Sometime I can go into it, because all these things I have got no earlier exposure. I just consult some online resources, I find out. So that 5G infrastructure I have not. Once we go to the 5G infrastructure, say everything, whatever you are asking, it will be clear. That, please forgive me for that. I could not go detail about it. It is Future Railway FRMCS. Future Railway Mobile Communication System. So I was very nicely left it for future, not for today.
No, thank you. No, absolutely.
Welcome.
But it was very nice that this presentation was organized. And RNC sir, hope you're there. Sorry, last few months I could not attend on some of the things, but it was very nice that this presentation was organized, and I'm really happy to see that. RNC sir, thank you very much. And
okay, thank you very much.
Thank you.
Therefore, we hope that you have enjoyed today's Tech Talk. Thank you, Mr. Saha, for your inspiring presentation and for joining us. to the...
Sorry to interrupt. I will forget my great regards to Dr. Patranovish, who I have been honored by his presence, even though there has not been any question from him. But I am honored by his presence that I got him in the beginning. He was there. I don't know if he is there or not, but my utmost respect to him. Thanks.
We extend our heartfelt appreciation to our beloved teacher, Professor Rabindranath Chakraborty, for his inspiration and efforts in making this program possible. Gratitude is also due to the Applied Physics Alumni Association and the teachers of the Applied Physics Department for their dedicated support in organizing this event. Thank you all once again.
Thanks.
Thank you.
Thank you. Thank you.